Okay, welcome Cisco Cohort 2. This session is being recorded and will be posted later today in the recorded presentations link for this class on MyTC Blackboard. And today we're going to be looking at this lab 6.3.2.7, exploring the router physical characteristics. And you're going to plug in your console cable into this and type some show version type commands and see what's going on with the router. First of all, for the benefit of those people that are viewing us synchronously and asynchronously, I'm going to very briefly, quickly show you how to get connected to this router should you be running the packet tracer program and you're off campus. And then I'll actually connect to my real router here in the laboratory and complete the lab using the steps on that. Okay, I'm going to, let's see, camera on, microphone on, recording on. I'm going to go to a packet tracer. Hang on just 1 second. Here's packet tracer. Where's packet tracer? There it is. Oops. Bring up packet tracer. Bring up the prompt. Okay. Let me go ahead and reset packet tracer back to its default mode here with nothing on it, and I'll show you how we get this particular router for today. I don't want to save anything. So when you started packet tracer for the very first time, it may ask you, if you haven't done it recently, to log into your Cisco Network Academy account. And they did change that prompt a couple of days ago. It's real confusing now. It's still, you still have exactly the same username, which has to be an email and the password that you made up. So for the purposes of this lab, we want simply a 1941 router. That's all you got to provision in packet tracer for this to work. So the way I'm going to do that is I'm going to bring up, here's my default packet tracer page. Nothing's been provisioned yet. I'm going to go down and click on, oh, I'm sorry, the lights. I'm going to dim the lights a little bit here. There we go. That's the lowest light setting I've got. That's the projector setting. So I'm going to go down and click on, by default, it should already be clicked on the routers. And we want to pick the 1941 router because that is the one that corresponds exactly to the router we have here in the classroom. The lab is written assuming you have a 1941 router. So I'm going to click on that router. I'm going to bring in the topology. And then if I click on it, you can see, let me zoom in here, expand this out a little bit. You can see the packet tracer representation of the router here. And there's a similar photograph of this in the lab that we're going to step through today. So looking, my mouse, okay, good, my mouse is going here. So we've got an on-off switch. In packet tracer, if you want to add an option to it, for example, our routers here in the lab actually have an extra little 4-port switch built into them. If I wanted to put that switch in there, I have to turn off the power first, so I have to turn off the power. And I'll pick the switch. And then I'll drag the switch into an open port. And then I'll turn the power back on. And then when I click on the CLI, I'll be able to see the router booting up. So here's the baby blue console port. You could unpack a tracer if you wanted to. You could provision a PC like a PCA and then connect the PC to the router with a rollover cable. And then you could go into the PC's desktop icon and pick that terminal program and you could connect to it. It's kind of like Terraturn. But when you're in packet tracer, you can just click the CLI prompt and it takes you immediately to, as if you were telnetted into it or consoled into it immediately. There's an auxiliary port present on these routers, which is not a CCNA topic. Sometimes in the good old days, we would attach a real fast T1 line, one of the fast interfaces, and then we would attach like a dial-up line, like a dial-up Hayes modem to the auxiliary port. And if the system engineer at the home office got a problem with a router in the field and the T1 line was down, he couldn't get to it, he could dial into it with the dial-up modem over an analog telephone line. And then he would be able to go into the router sort of like a backdoor, out of band management, and maybe try to figure out what's going on. Maybe somebody forgot to no shutdown or something to get that serial line going up and up. Then we have our 2 Ethernet ports. And then the routers have got some USB ports as well that can be used for things like if I want to back up information from the router, like the startup configuration, or make a backup probably the iOS, I can copy it to the USB drives just like you would on a desktop PC. I can also maybe update the iOS that's on the router with a new iOS that I placed on the flash drive after I downloaded it from Cisco. Or what about this? What about if your router dies and you backed it up, you backed up the startup configuration before it died because you should be good backed up. If you don't have a good backup, how are you going to restore something when it goes up in smoke? It is irrational to expect things never to go up in smoke. They occasionally go bad. You have to have backups. That's part of IT management, is being ready for that. So if this device went bad, of course, I would just call my Cisco, the contract service maintenance contract, SmartNet that I have with Cisco, and say, oh, this is a crucial operations router, and you must send me a new one, Federal Express, an hour ago. Get it here fast. And they'll send it to you, Federal Express. You'll probably get it next morning. You can bolt that new router in and take your thumb drive with your backed up configuration from the old router that burned up, and just copy that startup configuration to that new router, and you're back in business real fast. That's the purpose of those. Another purpose we can use those USB ports for. Okay, I'm going to go ahead and this is the lab we're doing today. It's in here, and this is the lab we're doing today, where the topology shows that we just have in the real world here, in the lab here in school, we actually have to have a router and a desktop PC. You guys that are here in the classroom, you logged into one of your desk positions with the X on it, which are the ones connected to the routers, and you run the Terraterm from that one, and you'll be able to connect to your router. If the regular desktops that don't have an X on them, they only connect to the switches, but we need to see the router today. Okay, so I'm going to now go to, I've showed you guys at home, the asynchronous and synchronous viewers, how to get started on this with Packet Tracer, where you're in the Packet Tracer prompt, and you can click on CLI, and you're connected to the router, and you can do whatever he tells you to do in a particular lab. I'm going to switch to the real machine, though, and pick up there here. Okay, so let me see. I'll need to minimize this, and minimize this, and minimize this. How many copies of Packet Tracer are running here? Okay, here's the real Terraterm I have really connected to a router. And when the routers boot up, they take about 3 or 4 minutes to boot up. You'll see a bunch of weird stuff up here on the screen. It kind of vanishes off the screen. We're going to talk about a command called show version that sort of brings it back on the screen so you can review, how much memory does it have, how many Ethernet ports does it have, and things of that nature. And generally, it's going to stop and ask you this question we see at the bottom of the screen. Do you want to go into the initial configuration dialog? Yes or no? And we're going to say no, because we're going to type in the actual commands ourselves. The purpose of the initial configuration dialog is if there's a router that's shipped to a remote branch office and there's no Cisco guy there, the guy on the phone, the engineer from the home office, can talk him into answering enough questions to get it up where it's just barely connected. And then the engineer can come in and get it fully connected. If you happen to accidentally answer yes to this question, what it takes you is a bunch of management setup, simple network management protocol. We don't get that until fall. Oh no, what am I supposed to do here? I'm stuck. So if you accidentally answer yes on this, all you have to do is type the Control-C character, and they'll take you out of that. To what happened to if you should have said no, N or NO for no. And this is a Cisco annoyance. It looks like it went dead. But in a few seconds, we're going to see a few lines of static stuff up here on the screen. So here it comes right here. And I'll be able to start configuring the router. Actually, we're just going to do some show commands. We're not going to do much configuration on it. Let's say I am taping. The mic is on. The camera is on. Good. Okay, so on the first page of the lab, required resources. One router. If you're doing a Packet Tracer, you drag that router, that 1941 router, into your topology. One PC, if you're doing Packet Tracer, you just click on the CLI tab on the router. You guys are in the lab, you have a PC, and you can use Terraterm and connect to that COM1 port and get connected to that. Did you get your COM1 up yet? Did it ask if password, or did it say it just has this? Is that okay? Good. You don't have to be rich. Yours asking for a password? Okay. Let me fix that real fast. Reboot your router. Get a password Cisco. Go to produce X mode. Password to class. Erase the configuration. And it'll go dead for about 3 minutes and put stuff on the screen, and then it'll come up and ask that question. It'll look like that question. Do you want to go into the initial configuration dialog? And you can answer no to that. So here in the lab, our baby blue console cable, that everybody's workstation has got that baby blue cute colored cable that comes out the back of your PC and goes into the purple plug on your patch panel. That's what we're using today. And that's connected to the router. There's 24 routers. There's 24 switches in the racks in the back of the room. And you're connected to that router, and you're going to be able to see something very similar. I've got a router exactly like you guys have got. Okay, identify the various parts of the Cisco router. And there's a question up there on the top of page 2. It shows a picture of the router, and we're supposed to be able to identify the power switch, the management ports like the console port and the auxiliary port, the LAN interfaces, which is the two yellow colored Ethernet interfaces. And on the front of the router, I'm on page 3 now. On the front of the router, there are some little lamps that light up. Now, normally, the front of the router, that's boring. Let's look at the back of the router. That's where all the action is. That's where all the plugs are located. So when you put this in a rack, people put this in the rack, they put the pretty front side out, and you can tell at a glance if the router is not booting right because the little lights on the front will not be in the green status. They'll be blinking red or something. You know that router's got a fault with it. We're going to do the action on the bottom of the router. So there's some lights that are labeled CIS, ACT, and PoE. I'm on the top of page 4. The system light is normally solid green. Let me see, look at mine. It's solid green. Mine's finished booting up. So on my router, which is booted up properly, the system light is just on, solid green. Then there's a system activity light next to it that's blinking. So if any packets or any activity is taking place on the router, that light will blink as activity takes place. And then the PoE, didn't we talk about PoE, guys? What's PoE? Power over Ethernet. It's a way that we send power to things like Wi-Fi access points, like that thing up there, IP surveillance cameras, Cisco telephones. All those things use power over Ethernet, so we don't have to run an electrician, have an electrical circuit up in the ceiling somewhere. It costs $250 to get an electrician to do that. Oh, we're a junior college district. We pay $500. And if the packet processes, it'll blink. It's kind of like the light bulb on the back of the NIC card, a network interface card, Ethernet adapter in your desktop PC will blink as activity occurs, or a switch port we plug something to a switch port, the switch port will blink as activity takes place. Okay, I'm going to go to part 2, and we're going to do some iOS commands. So I'm in the middle now of page 4, and my router should have booted up okay. So I got the default host name of router. Now, before I do what he says, I'm going to type a command called show the running configuration. Wait a minute. Just to prove there's no existing configuration, let me go to the privilege exec mode. How can I tell if there's any previous configuration on the router? There will be a saved startup configuration of some sort. So if I show me your startup configuration, he tells me there's none there. This is a completely erased router. That was a dead giveaway when it came up and it said, do you want to go into the configuration mode? It never says that unless there's no startup configuration. It's a factory fresh router. Now, let me blow your mind here. Show me the running configuration. What the heck is all this running configuration? It's supposed to be a totally erased router. That's just the default configuration. All the interfaces are in the shutdown state because it's a router. There's no passwords. It has the default host name of router, and we're going to give it, R1 or something like that when we start to configure these things. So at part 2, step 1 on page 4, I'm supposed to type enable. I did that. I'm at the privilege exec mode. And then we're going to type this command, show me the version, which is all the stuff that rolls off the top of the screen. This is 3 pages of stuff. I'm going to stop on each page. So the first page, it tells us the version of software that's loaded on this particular router. What's got version 15.4 of the iOS? Fairly current version. The router has a bootstrap, a Ramen mode. We're going to use that in a later course to do password recovery. Normally we don't use the Ramen mode because it's not powerful enough to route packets. It's an emergency disaster recovery only. Recovering passwords, resetting a password that you don't know, or copying a new iOS there if your iOS somehow gets clobbered. So when I scroll to the second page, excuse me, I can see the interfaces that are pressed on this particular router. I can see how much memory it's got. These particular routers have got non-volatile memory, which is where the startup configuration is stored. Not much memory. It's just a few hundred lines of code usually. So the capacity of that, 255,000, that's plenty of capacity for the biggest startup configuration you would ever need. Then it has about 256 meg of a compact flash memory card. That's storing the iOS file. That's plenty of room for that. This is not Windows with 60 million lines of code, and you got to have a 50 gig drive before you can install Windows 10 on it because it's so big. And this particular series of routers Cisco has a licensing scheme. The router comes with the IP-based configuration, which is all your normal TCP/IP routing functions. And we've added a security license to these routers to do, if you're going to take CCNA security or a course like that, some heavy-duty security stuff, it has this module software code loaded in here. It can do some extra features. If you were being a data center, you might want to load the data license key. If you're doing a network essentials, there's a key for that. So if you got IP phones or any other things, there's a key that you can put on your machine to make it perfect for that. For the purpose of a Cisco Networking Academy, all we need is IP-based. The configuration register, 2102. The configuration register is what we're going to use in our capstone course next fall if we have to reset the password. Sometimes people leave the company and they got mad and they changed all the passwords on purpose because they were mad. That's sometimes things like that happen. So there has to be a method for us new system administrators when we come in. If you get hired to work as a Cisco guy at a company and they say, we had to fire the last Cisco guy and he changed all the passwords. Can you reset the passwords? Well, sure, you can do that. As long as I can get physical, up close and personal, if I can touch the device, I can reset the password. Same thing with a Microsoft server computer. You got your Microsoft domain controller, and the guy never wrote the password down and got hit by a bus, or he left the company and got mad and changed the password. Can I reset the password, the administrator password, on the Microsoft domain controller? Yes, if I can touch it, you betcha. I can put a USB thumb drive in there and boot up a version of Linux that'll go into the registry, the SAM database, the security account manager database that has people's names and passwords in it. I can just reset the administrator password or something like the enter key and go in there and take control back of the device. So at the middle of page 5, he's asking us a bunch of questions. Based upon the output of the show version command, answer the following questions. So the first one, what version of the Cisco iOS is this? I'm going to repeat the command because that was told at the very top. Version, here's the version right here. Version 15.4, fairly current version. He's asking about the Bootstrap program. This is the Bootstrap program, the ROM monitor program. If for some reason the iOS gets corrupted, it'll go into the ROM monitor mode, and you can do your troubleshooting. Or if we need to reset the password, fix the iOS file or update the iOS file, we can go to the ROM monitor mode. How long has the router been running without a reboot? And this router has been running for 52 minutes. And how was it reset last time? By power on, power off. I turned the power off and I turned it on again. I'm not going to read each and every question here, but they got some questions here. Now, let's go to the top of page 6, and let's do the show interface command. So I'm supposed to type show interface gig 0/0. And what is all that? Do I need to list? What are all these lines for? What's the most important stuff here? Here's the most important lines. Oops. Is it up and up? Or is it down and down? Or is it administratively down? All ports, interface ports on Cisco routers, by default, are administratively shut down. Not like your home router. Your home router automatically, tries to contact the cable company and log right in. And it tells us the MAC address of that particular port. If there are any errors that have occurred on that, we'll have a bunch of numbers here. We got a bunch. Oh, good. We got 0 errors. This is good. We want all those to be 0. If we get big numbers there, oh, we're getting collisions. There's a frayed wire somewhere, a wire that's got some corrosion in one of the contacts. We're getting a bunch of errors on that particular line. So we can use this to do troubleshooting skills. We'll get this in a later course, how to read this and try to find out what's going on. So little b at the bottom of page 6, given the output of this, what is the hardware type and MAC address of this gigabit Ethernet interface? And here's the line right here. Hardware is, it's a gigabit Ethernet hardware. And here's the MAC address. Notice it has the same MAC address printed twice. Didn't we have this back in the switch lab where it had it twice and it said BAI for the second MAC address of the switch and it was the same number? The BI is the burned in address. That's the physically burned into the read-only memory of this device. And normally he uses that by default. So they're both the same. Now, if you were doing something weird with access control lists or something like that, you might want to change what everyone else thinks your MAC address is. The only other reason I can think of wanting to do that is you're a hacker. And you don't want anybody to know your real MAC address because they're going to track you down that way. Okay, let's see. Do I have a serial port in this one? Yeah, I've got serial ports in this one. Serial ports, the use of serial ports, we used to use serial ports to tie our routers together in our labs, R1, R2, R3. Serial ports have been de-emphasized now. If you had the old T1 line or something like that, ISDN line, you would use your serial port to connect this. But all our routers are equipped with, I think, did I equip them or did I tear them out? Let me take a peek here. They're equipped with them, I didn't tear them out. Okay. So even your router's got, so you can use that command if you heard personally in the lab. And it says type at the bottom of page 6, show interfaces serial. If we do this in packet tracer, you won't be able to do this unless you provision the serial ports in there. 0/0/0/0. So we get a similar report here, but it's about the serial port. What is the frame encapsulation type? I think it rolled way to the top here. Here it is. Encapsulation is HDLC. At the data link layer on serial ports, HDLC is the default encapsulation type for all Cisco devices. If I just plug two Cisco serial ports together, it's going to work just fine. It's proprietary to Cisco. So if I wanted to connect with other manufacturers' devices, I would use a protocol we don't really study much at CCNA anymore. We just look at it conceptually. Point-to-point protocol, maybe. Serial frame relay, ISDN, protocols that aren't used much anymore. So by default, it's set to HDLC. You shouldn't have to worry about setting that type because there's no longer any labs where we do anything with the serial ports. What is the hardware type? This line here says hardware is WIC MRD serial. That's the hardware type of the serial, that serial card that's plugged into there that has the two serial ports that we're not going to use anymore. And the interface is down and down, administratively down. If I type no shutdown, it won't be administratively down anymore, but it can't come up and up until I connect a wire from this serial port to another serial port and they match and they'll both come up and up. Okay, I don't require the reflection questions, but let's look at them anyway. Why would you want to use an HWIC expansion slot? And if you look at our routers in the back of the room, they all have a 4-port Ethernet, little mini 4-port Ethernet switch plugged into them. That's an option you can get from them. So if you were a branch office and you just needed a couple plugs for a server and a couple salesmen or something, instead of buying a whole separate 24-port switch and having another thing to plug the power into, you could put this 4-port switch and it kind of makes it look like your home router. What does your home router got on it? 4 ports, 4 local Ethernet ports, and then it's got the WAN port that goes upstream to the provider. So on our routers, it's kind of the same way. It's kind of like take a $1,000 Cisco router and turn it into a $25 Linksys home router. It's got the 4 ports that can go to the LAN, and it's got the Ethernet port, the gig port you can use to uplink to your provider or maybe back to your home office. So they offer many different devices. If you go into Packet Tracer, you'll see I put that 4-port switch in the Packet Tracer. I provisioned the 4-port switch. In Packet Tracer, I had to turn off the power and plug the plug in. Just like in real life, you have to turn off the power before you plug an expansion card in. Why would I need to upgrade the flash memory? Well, gosh, it only had 256 meg. I don't think you can buy flash memory with 256 meg on it anymore. Isn't everything 40 gig now? Well, what if there was a new version of the iOS that came out and you wanted to upgrade your router? And there was a new version of the router, the iOS file was too big to fit in the existing flash card. This actually happened right here in this room to me. We had some last generation routers, were 1841 routers, and they came with a 64 megabyte flash memory card, which was fine for the version, I think I had version 12 of iOS loaded in them. Well, we wanted to upgrade them to the version 15 of iOS. Two big problems with those routers. The flash card wasn't big enough. This would be like if you have an old computer with Windows 7 and you want to install Windows 10 in it, and the hard drive doesn't have enough space. And what's going to be the other big problem when you install Windows 10 on that old 15-year-old Windows 7 computer? You probably don't have enough RAM memory. And the manufacturers deliberately changed the DDR3, DDR4. No, you can't use your old memory. You got to buy brand new memory. It won't work anymore. So I had the exact same problem with the Cisco 1841 routers. They only had 128 meg of memory in them. I had to upgrade them. So I upgraded them. I think I made up to 256 meg. They happen to use laptop memory. And so they were upgraded. So if you might need to upgrade the flash memory as well as the RAM memory, if a new version of the iOS comes out for the current model that you have, and there's not enough space to put the iOS file itself, and maybe it requires 256 meg to operate in. Most of the current Cisco iOSs require 256 meg or 512 meg of RAM to operate properly. What is the purpose of the mini USB port? It's right next to that baby blue console rollover cable connection. And the baby blue console cable has that RJ45 in that plugs into the baby blue console port of this router. And the other end has got that RS232 DB9 mini RS232 connector, the COM1 port, the standardized IBM PC one. Most PCs don't have COM1 ports on them anymore. Ours do. Our ones we got in here, we were lucky to get them. But what kind of serial port does every kind of computer have now? USB something. It might have USB 3, it might be USB 2. Everything's got that. So you can buy a replacement cable. I don't think I have one here to show you. You can buy for $10 off of Amazon. You can buy a plug that has USB 2 on one end, plugged into any laptop or PC, and the other end has got the RJ45 that plugs into the console port. And it's got a little built-in serial chip in that little cord. For $15, you can get the USB 3 one. You know what I like about USB 3? It plugs in either way. You know the rule of USB with USB 2? You try to plug in the wire, it doesn't work. You turn the wire around, it doesn't work. You turn the wire around the back the first way it was, now it goes in. That's what I call the rule of USB. It never goes in the first time. So the purpose of that mini USB port is if you have a laptop or something, you don't have anything but USB ports, you can get the USB cable or the adapter. This is what we're using on our PCs here in the laboratory. Your COM4 port is a little adapter. Let me see, what color is it? It's black in color, and it plugs into a USB port on the back of your PC, and then it's that COM4 port. So if you have a second router or second switch, you can configure it. So the purpose of the mini USB port is if you don't have an older machine that has a USB thing or an old data terminal lying around, like a VT100, you can use that. Okay, last question on reflection, and we'll be done. What is the purpose of the ISM WLAN indicator light on the back of the router? So what are we not? So far, we've taken our $1,000 Cisco router, we put about $300 worth of extra option cards into it, and it's basically really nothing much more than a $25 Linksys home router. Except that a Linksys home router has still got something that we don't got on our routers. What's that? The Wi-Fi? Well, you can plug a Wi-Fi module into these branch office routers, and now they're going to be like your home router. You can set up a Wi-Fi SSID and have your wireless connectors attached to your wireless devices attached to that. When you plug that device into one of these back panel ports, I plugged a 4-port Ethernet switch into it. There's 2 slots. I could also plug a Wi-Fi circuit board into the second slot and give Wi-Fi service to that branch office. So whenever you plug that in, that ISN WLAN wireless local area network light will come up. Okay, I think I've covered everything on that, so hang loose. I'm going to stop the recording.